Well, hi, and welcome to my shop. Thank you for coming and spending some of your time with me while I work on this radio. The next step along the way is to do the oscillator and RF adjustments for the shortwave bands in this radio. I've done the IF alignment for the FM band. That kind of went okay. And I've done the IF alignment for the AM side of this receiver, which went fine. So now it's time to do the shortwave. I think the first thing I'd like to do is just listen to a little bit of shortwave on here and get an idea how well it's working. This isn't the greatest time of day to be doing this. But then any time of day you should be able to pick up some shortwave if there's any out there to get. Occasionally there's no shortwave in the world, or at least in this part of the world, because of activity on the sun can cause effects that will just completely eliminate it. So we're going to start on the broadcast band here just to make sure the radio is operating. And I still have a camera on the Magic Eye here, but it's not on the screen just yet. Here it comes. I'll turn this up a little bit. Still pretty fuzzy. Yeah, I'm not sure I solved the problem with this. Now I have to admit the noise levels in here are much stronger than regular AM stations. Let's see if we can pick one off down here. Okay, so there's a station right there. Swing the radio around to get it a little better. Oh, don't have it on full power yet. Let's turn it down a little bit. Give it everything it's got. I'm spinning the radio around. Maybe my camera tip up and down here a little bit. Well, tuning it now. You'll see, in my mind, this should always show a sharp line like this. It should never show a fuzzy line. So I think there's still something going on there. Okay, we'll switch now to shortwave 1. Tone control is really sticky. I'm getting the same fuzziness. Just does not seem right. That could be audio. That could be audio getting into this. Yeah, I think that's what that actually is. Okay, now we're on a band where I wouldn't expect anything anyway to be picked up. 2 megahertz, 3 megahertz. The other thing that's a little odd is can't turn the volume rate down still. And we've reached the end of the band where it's just faded right out. Let me come back a bit. Okay, so much for shortwave 1. Here's shortwave 2. Shortwave 2. What a difference. Okay, first of all, the volume's acting correct. The lines have gone sharp. Tuning now. Now I do not have an antenna connected, so that would cause a problem, wouldn't it? But look at that, the line is just down there. Okay, let's put an antenna on. This is a right to an outdoor antenna. Oh my gosh, expected. Lots of noise. Tuning again. Tuning nothing. Nothing at all. Well, this does not bode well for shortwave 2. Shortwave 2, eh? Let's try the button and just see if it isn't the button making bad contact here. So the sound kind of disappeared. So all I'm doing is this. She's dead. Doesn't look good to me. Let's go back to shortwave 1. That's with the volume at 0. Okay. Okay, I've seen enough. I've seen enough. I have to put it on shortwave 2 just to silence it. Well, there's something more wrong in this radio. I don't think I can go forward with the shortwave side of things. There's definitely something's not right. And I'm willing to gamble 50 cents that I've made another mistake in this radio when I was working on it, and I haven't found that mistake yet. I thought I did. When I moved that capacitor, in the back of my mind I'm thinking this just can't be the case. This just can't be the case. It's just can't be the case of what is causing some difficulties here. I think my observation on the Magic Eye is valid. I think there is audio getting into the AVC system. The audio should not be getting there. There's a couple ways it is kept out. We're going to have to go through those ways, identify the capacitors involved, check and see what I've done on the capacitor replacement side of things, try to find a problem. I think there's a problem in here. You know, that in itself can be a problem. How do you know for sure there's something wrong? Maybe that's how the eye is supposed to work. Maybe that's how this radio works. It's how the guys designed it. Maybe. Maybe. But I think I gotta go with the idea that there's something wrong here. Something's not right. Well, let's start by looking at the schematic here and seeing what we can figure out from it. The audio for the AM radio is developed in here and in conjunction with this diode. The result is a DC voltage, because of the diode here, is developed. It turns the IF signal, the 460 kilohertz coming out of here, into a DC voltage that varies with the strength of the IF signal. So tune in a strong signal, get a bigger voltage. Now also the audio is almost recovered, if you like, at this point. It is kind of recovered, it just needs to be filtered better. So in this direction, no DC voltage can travel unless this capacitor is in trouble. And that's an interesting question right there. No DC this way, assuming everything is correct. So the DC is intended to influence the circuits in this direction. So we can see this is the main, we can call this the AVC wire, coming through 100K resistor there. This is a 500,000 resistor here. On the other side, we'll have to flip to the other page to see the rest of this. We have a upper wire, the main wire, if you like. This one here, if we trace it back, is the output from the FM detector. So this is a DC output here. Comes from here, just like the AVC. It's on this wire. We'll see in a moment that the Magic Eye is driven either by a connection to here or a connection to here, one of those two. Let's go there and see. Okay, so here's the Magic Eye. Here's the three wires, 1, 2 and 3. And you can see the switch here is selecting between 2 and 3. 3, this one down here being the AM AVC voltage. If you notice the FM, a little hard to see on this schematic, this page now, but the FM AVC doesn't go anywhere except to the eye here. That's all it's doing, is operating the eye. So if we continue to follow the main AVC bus, this would be the AM bus. We come across the capacitor I fiddled with, which I'm got big question marks about how effective that really was, what I did there. And carries on, goes through this large resistor, 1.5 megohm resistor, which I measured at 1.3 and saw that it was not a 1.5 megohm resistor, but a different value according to the color code on it. So was that really the right resistor? Did I really follow this correctly? I think so. So the DC gets to here. At this point, it doesn't have anywhere to go. It's got a grid going nowhere and this capacitor blocking it. So the entire DC circuit consists of this. And back on the other page up to the source of the DC, which is the rectification of the IF signal. A lot of radios, there would be another tube. There would be an RF tube down here in many radios that would also be controlled. But this one, the AM comes from the antenna through a few coils and other doodads and gets to the grid of this tube. By the way, it's grid 1 where the signal is supplied from the antenna. Grid 3, this one here, if we follow it up and over and down, you see it's coming from this set of coils, and these are the oscillator coils. And this is what I'm a little interested in too. And shortwave band 2 seems to be receiving stuff, even if it is just noise. Band number 2, didn't we pick up a station on it yesterday at 9.3? I was curious if the local oscillator was even operating on band 2. And still I'm curious. Could be there, could be weak. Could be part of the picture. So we're going to do a little investigation into the local oscillator and how strong it is. But it's another investigation that's got a fair bit of uncertainty in it when we do it. So a possibility here would be this resistor open. If this were open, no AVC voltage would make it here. It would still make it to the eye. You still see stuff going on. But this would be left unbiased. And since the bias that's coming in here is progressively more negative with a stronger signal, the more negative you make this grid, the less amplification through this tube. But if this is open, then this is just sitting here. It's liable to pick up its own biasing a little bit, but it would be wide open in terms of amplification. So this would be on high. This radio would be on high all the time, no matter what it was picking up. Is that really what's going on? So we can see the eye closes when I pick up stations and noise and stuff like that. But the eye may not be reflecting what's happening on this grid if this resistor is open. So this is an easy thing to check. This side of the resistor goes nowhere. So we should be able to read right across it. But I did read across it. I got 1.3 ohms, 1.3 megohms. Well, we should repeat this because I'm not absolutely sure. In the meantime, looking at these diagrams, I discovered there is a map or a layout, a component layout map I wasn't making use of. So you'd be more certain about where this R114 is. That's a good idea. Why don't we start right there? Where is R114 and what condition is it in? Let's do that. Okay, so making use of this diagram, too bad I didn't notice this existed. So this is showing the board. The board is here. Showing the tube. The tube you can't quite see, it's just hidden behind here. You can see the camera's looking right at where the resistor is. There's the resistor, R114. In the schematic, R114 is 1.5 megohms. In the radio, so there it is. You can see the color bands. Let me put more light on it here. Well, I would say what the heck is going on with that resistor? The first band, what color is that? Well, we could guess it's brown. It doesn't look brown, but we could say, well, okay, maybe that's brown. Let me look with my own eyes, because sometimes the camera does things with it. Yeah, it looks very different. My own eyes, that looks kind of a goldy, brownish color. So we'll call it brown. So we'll call that brown. Yeah, it looks a little brownish with less light. So that'd be brown, black, green. That would be a 1 megohm resistor. The gold band. But I measured it at 1.3, didn't I? Let's repeat the measurement here. Now what if one of the capacitors involved with this resistor are shorted? Well, one of them is brand new, so it's not likely to be shorted. That's supposed to be a... Here we are. It's not showing anything. I'm on the 6 megohm scale. Oh. No, it was supposed to be a 1.5 or something like that. One. That's 1 megohm. Well, why didn't it read on this scale? There we are, 1 megohm. It is what it says it is. 1 megohm. Probably not a critical difference in the way the circuit would operate. Why in a schematic 1.5, but in reality it's a 1? I don't know. But it's in exactly the right position. Okay, that didn't help. That did not help. Now, sometimes there's a chart of pin resistances for the tubes. There isn't one for this radio, I'm afraid, unfortunately. What to try next? What to try next? I'm not sure what to try next. So the next thing I'm a little suspicious of is this capacitor here, 4700 picofarad. Now I have a replacement I put in, and of course I didn't bother making sure the numbering was visible, so the value of the capacitor is hidden. But when I compare the body size of the capacitor I put in to a known 4700 picofarad capacitor, they don't match. I mean, I got the wrong capacitor in right here. That might fail to allow enough audio through this way. It may allow some of it then to go that way. I don't know. I'm going to check this. I'm going to check this carefully here. So one of the things I've come to realize in doing this kind of work is that every time you go to do something, there's a chance you introduce a new problem. And here's one. So let me just flip back for a sec. You can see where the camera is aimed. It's aimed right into this area here. That's what we're looking at. Can you see the unsoldered wire sitting right there? Right here. Now how the heck did that happen? This is a piece of wire up above. It's not even a component. It's a piece of wire. How did it get unsoldered and pulled away so far? Guilty. I must have done that. So we're going to solder this wire in and see if it makes any difference at all. I have to guess what happened there was when I was fishing for the right thing to unsolder, I hit this with the soldering iron. Somehow, I don't know, I guess I poked at it and bent the wire. I don't know. Shame on me. But maybe this is the essence of the problem here. Maybe they had no business doing anything to that wire. But somehow I did. Okay, let's solder it back here. Now it may have been making electrical contact. It may have been just really quite fine. Just sitting there. Didn't look like it. Here we are. Okay, now that is connected without a doubt. We gotta try this radio again and see if we haven't fixed the problem. Oh my gosh. I wasn't even looking for anything like that. That's why it's not harmful to spend a great deal of time looking at these things. It takes a long time to see stuff often. Especially to see stuff you're not really even expecting to see. Okay, so we still have the signal generator looped around the AM antenna. We have the FM antenna unplugged. Let's plug it in. I don't have a shortwave antenna connected, but I will when I want to. And let's put that camera back in front of the eye here. Since really it was the eye that was raising all the suspicions. Here we are. Okay, switch on the radio now. Let's start with broadcast. There we go. Dim pulse normal. Okay, let's see what the eye does. Maybe a little bit out of focus here. Yeah, that's a little better. Nice sharp straight lines here. So that's what it really was. Behavior is now completely normal. Could this have done something with shortwave 2? Bring the pointer right down here. So we're on broadcast right now. Okay, we'll flip to shortwave 1. Wait a minute, let's go back to shortwave 2. Okay, so that's the volume absolutely minimum, and we were listening to it. So it's still got too much volume. That's a problem worth having. If we were looking at it a little more like this, you'd see it. In case you're wondering why this is so small down here and bigger up there, it's just kind of an angle thing. Now, I think we need to... This is with no antenna. Wow. Okay, let me get the antenna here. We'll plug it in. Volume rate to minimum. Wouldn't expect to pick anything up here this time of day. This is 3 megahertz, and there's only one thing that might be there. That'd be 3.3. No, 3.3 is a where a time signal is sent from Ottawa, which I can pick up here. Now we're on shortwave band 2. It's really quite bad. What the heck is that? Overloaded lights here. Got rid of some of it. Frequencies are, we're around 15 right now. Behind this terrible noise, let's put the ground from the antenna on and see if that makes a difference. Didn't that make a difference? Wow. Now we're picking up. Let's watch the eye action on this. I'd say there's no eye action. So all those sounds as I tune across, those could be real interference signals that the radio's picking up. It can't help it. Or, okay, now we're getting in. This is the European shortwave band, 13 megahertz. Didn't hear anything.
Personas han sufrido presión por hacer una directa a través de Facebook. ¿Tú crees que tengan miedo que estas personas se unan al movimiento de las damas de blanco por la fuerza que tienen las damas de blanco dentro y fuera de la isla? Es claro, evidente. Evidentemente porque traen mucho con...
Get yourself ready. The truth is, you can't. Neither can I. No one can. Just don't until you've quit sinning. You're
Okay.
Fleur last weekend in Montreal, but Jeanette's Boys featured prominently.
Whoops. Yeah, that woke everybody up. strong is that noise? Perfect. Everything's working perfect. Oh, is that stupid broke wire? Wire I accidentally unsoldered without realizing it. And connecting it back up has solved the strange eye behavior. Okay, that's great. Fantastic. So we get back to doing the alignment. So we're on shortwave 1. The information I have to guide me on which of these coils to adjust is unreliable. So we got to figure it out. Now these were all AM adjustments. Take a guess. It's got to be these. Why this one? Oh, it's this white wire. It's this white wire. Position of this white wire is critical. Oh! Really critical. What's happening? Shorting to the chassis down here. Just a fraction away from the chassis. That's better. Okay. Okay. I have to listen to that noise. Now, how should we do this? So some of these are going to be oscillator adjustments. Maybe one of them will be an oscillator adjustment. The other two could be RF. We want to recognize which one is the oscillator adjustment. So the way to do that is, because all it does is retune the radio, it doesn't make it stronger or weaker. So you tune in a signal, noise, interfere with it, coil. It's not doing anything. This is not enough interference. Let's go on shortwave 2 and see what this coil is doing on shortwave 2. Okay, we gotta tune in something, anything? How about that guy talking at 9.3? There you go. Not a guy. Last chance. Well, okay, this is kind of interesting. So this appears to be associated with band number 1. Oh. I thought that wire was broken there, but it's not. This is definitely the oscillator here. The radio retuned because I repositioned one of the wires. That's how sensitive this all is. Very good. Okay, we're set to go. I think this is part of band 2. Band 1, rather. Okay, so what do they say in the instructions here? In German. So we'll just look at the short wave. Eigenmarke 6.1, oscillator H, and the other one I. This will be an RF adjustment. Then go to 17, oscillator K, I'm going to guess what this is do it over and over again. So this is the only shortwave band in here. They talk about H and I at the 6.1. 6.1 would be right at the end of the band, I would think. Because on this radio, 6.1 is, well, it's right here. It's marked right there. 6.1 is marked. So they want you to do it at 6.1. And what do they want you to do? I want you to adjust oscillator and something else. Okay, pretty sure the oscillator for this band is here. Not so sure? The low end. Jeez, I'm not sure. Let's get 6.1 fed into the radio though. I'll take it off the antenna. Still trying to pick up stuff. And we'll take the oscillator, which is up here. Now it already has a signal simulator box. It has a I should be able to hook this directly to the antenna. That's what I'm getting at. Okay. Fairly low signal level. Way off on frequency. 6.1. So we're going to want to dial in 6.1 here. Oh, it's almost dead on. 6.1. Okay, medium signal. Do we hear it? Here we go. I don't hear it. Higher level. What's not working out here? What's not working? We have a very strong signal. Let me check the calibration up here. Okay, so we don't have a strong signal. Okay, now we've got a strong signal. 6.1, shortwave 1, shortwave 1. Oh, now I'm nowhere near it. It should be shortwave 2 if I'm going to try this 6.1 thing. So we'll do shortwave 1. Just checking its frequency accuracy here. What I'm doing is tuning this to exactly 2 megahertz. Yeah, let's get it right. 2 megahertz. There it is. Nice response on the eye. So we're looking at 2 on here, and we're looking at 1976. Let's put this to 2. This way we'll find out just how far off the dial really is. Okay. Go down there. So it's about the width of the needle off. Okay, we'll go up to the other end. 5. Again, this shortwave band, it won't get much use, if any, at all. 5. So quite a ways off here. 48.66. Okay, we'll dial this up to 5, and we'll find where it is. 5. See, it's way off here. It's way over here. So we should adjust the oscillator. Which one's the oscillator? We're at the high end of the band. I can watch either the eye or the meter. That signal's pretty strong. This is a fairly weak signal now, but it's being fed right into the antenna. Looking at the meter, right, the meter. No, that's right on. So 5 is 5. Going to this end. 2. Okay, so we're going to go down a little bit in the direction I want to go. Now we're going to adjust this guy here. Not the right guy. Not the right guy. This can't be right. Two reads 2, but it's the same adjustment, so we won't be reading 5 up here anymore. I hear it up here too. That's almost tied dead on. But was there another version of it? No. That's pretty good. I think that's good. Now the other adjustments are for peaking up the strength of the signal. Do that about the middle here, so that's 3. Okay, now we want to tune this in very accurately, get that meter up as high as possible. Let's go a little off 3. That's good. Let's go there. Okay, that's the maximum reading. See if we can get it higher yet. So we'll start with this adjustment here. A little higher. And then we're doing this one. Oh, that's it's peaked already. And we're going to poke this one, which I don't think should be part of this endeavor. I think every time I thought this coil was sensitive, I was actually approaching this white wire here. That's it for that band. Very good. Okay, on to the next band. Shortwave 2. Now what do they say in here? There is no shortwave 2, so it would be the same sort of deal. Well, there's only these 3 left. Looks like 1 oscillator and 2. It should be only 1 oscillator. Well, it can be a high and a low oscillator adjustment. Let's go up to, down to this 6.1 marker. Pretty sure that's a 6.1 marker, and we'll see. Is that 6.1 now? Right. You gonna hear it? Not gonna hear it. It's too quiet. Oh, I can hear it now. It's pretty much dead on. So let's set it to 6.1. That's just a short ways away. And I'll try to bring it in. Assuming this one's the oscillator. Here, yep. There we are. And the other two are I'm going to do in the middle of the band. So we're going to go to, let's say, 11 megahertz. Go up to 11. Make sure this meter's reading maximum now. Okay, now we try to peak up that. Sounds like it's tuning it. I misunderstood these. Sounds more like it's tuning it. This one here. And this is just, oh, this sounds like it's tuning it also. Shouldn't those be RF? Maybe it's one of these, gotta rock the dial a little bit. Don't think so. Okay, so we're at we're 100 short. Let's put this on 11. Let's see how bad the dial is. A little bit. But I'll bet you if I turn that other one, this one back here. I'm putting 11 on 11. Now receiving 11. Go up to the top here, 18. 18. Definitely tuning it. Okay, let's hear what we can pick up with this now. Will it be much different than before? Probably not, because it's kind of a condition thing. There isn't an awful lot of shortwave signals out there at this time of day to pick up. In fact, I've been listening to air traffic control over the Atlantic Ocean. And I've been using an SDR radio to do it. Cheap SDR radio, because the waterfall display helps you spot momentary transmissions like air traffic control and that. Okay, so we'll just do shortwave 2. We have the shortwave antenna connected, and we'll just start at the low end here. There we go. So this is 6-7 megahertz. Wouldn't expect anything down here. Okay, so here's 9. We start picking up stuff just around 9 megahertz. I would expect.
Water. And we detest that. Then Yahweh sent poisonous among the people, and they bit them so that many Israelites died. The people then came to Moses and said, "We have sinned by speaking against."
There's a distinct hum coming in with the signal too.
Intercede with Yahweh so that he will take the snakes away from us. And Moses interceded for the people. Then Yahweh said to Moses, "Make a snake image and mount it on a pole."
God said, make a snake image and mount it on a pole. This is the God who created the universe, telling people, put a snake image on a pole. So we're above 10 now. Nothing really in there. Get up above 11.4 or so, we should start picking up more short wave. Need to tune this very slowly. Is there a hum with this one?
Para finales de febrero, casi el 60% de la población estadounidense había contraído coronavirus.
Don't notice any hum effect?
En Estados Unidos, muchos de los casos pudieron ser asintomáticos o con pocos síntomas y según análisis de sangre, aproximadamente 100.
So I'm pretty sure that's Radio Marti, broadcasting from Florida into Mexico, into Cuba. But I suspect really it's just entertaining the Cubans in Florida.
To propose if the state legislatures get to ratify whatever to ratify, or if it'll be special state conventions. So when the 21st Amendment of the Constitution was ratified, the one that repealed prohibition, there were some states like Utah which did not want to repeal prohibition at the time, and local Congress did, because there are arguments on both sides of that issue.
You hear a station like that talking about American politics, you can't be sure if it's actually just a political station. I don't know that there are really any such things, or if it's a religious station backed by money out of religion. Because in the United States, religion and politics are so mixed together, you can't separate them. That's really not so good in my opinion. Okay, so we're at 13 megahertz. And we're getting into the 20 meter ham band. Can't really hear anything. Now we're getting up close to 15 megahertz. That's 15. There's WWV. Okay, I line the camera right up. We see we're a little off. 15. Now there's usually a station at 15140. Didn't hear it, and 15770. Very, very difficult to tune up at these frequencies. That's going to be 15770. Could there be anything up at 17? Could be. So this radio has these different bands marked on it. 49 meter, 41 meter, 31 meter, 25 meter, 19 meter, 16 meter band, but they don't actually mark the band limits. They just, I guess you could argue the center of the band is the center of these words. Because you're not going to pick up international broadcasting everywhere on a shortwave radio, just in certain bands. Nothing up here. Oh. Now you know what that is? I think it's this. Yep. It's very sensitive. So the signal generator is not connected, the power output is switched very low, and yet this radio is picking it up. It's good. Sensitivity very good. That's another way of tuning these radios. A strong station will cause a pop as you go by it. That's what it was. Very tricky to tune this radio. Very tricky. Now, how accurate is my clock? Not very accurate. Don't fade out on me now. Oh, I didn't hear him talk. Huh? What? I guess the voice just faded out a little bit, just at the wrong time. So, but I think my clock's pretty accurate. Well, there we are. Okay, so all that's left now is the FM alignment, which is a project for tomorrow. To run through all of that, but I'm pretty happy with the results here today. Hey, found my mistake once again. I hate to say this, but a lot of time in my shop is spent finding my mistakes. It's just the truth of the situation. Okay, but as long as I find them, that's okay. So thanks a lot for watching, and it's a beautiful sunny day outside. 3 degrees is the high today. It's pretty cold, but the sunshine is fantastic. That's where I'm headed. So thanks a lot for watching.